So in this video, we're going to do mass-to-mass stoichiometry questions. So that would be like if something was in grams and we still want it to be in grams. So our first question is, determine the mass of sodium required to react with 23.6 grams of aluminum sulfate. So the first thing that we need to do is we need to have a balanced reaction. So number one is to have a balanced reaction. So sodium, again, remember that you're trying to look for keywords, reacts with aluminum sulfate. So first off, I'd have to find out that aluminum was Al. Sodium, oops, let's try that again. So first off, I would have to find out that aluminum is Al, and it's 3 positive. Sulfate is a polyatomic. I can tell because it ends in ATE, and it's SO4, 2 negative. So when they come together, I would write that as this. Remember that because it's a polyatomic, it needs brackets around it to say that there's 3 of the SO4 molecules, not just 43 oxygens. And then it reacts with sodium. This type of reaction where you have an element reacting with one compound is called a single replacement reaction. And in a single replacement reaction, you will get the same thing. So you'll get another element and another compound. Knowing the types of reactions is going to help you try and get the reactions too. So this one is a compound, right? This is an element. And what we should get is another element, not of course the same one, and another compound. So in this case, aluminum is a metal and sodium is a metal, so 2 metals can't go together. So that means that sodium and aluminum are going to switch places instead. And so now what we're going to get is the sodium sulfate, and we're going to get aluminum. Okay, now if you can't figure this out, right, this is sodium is positive, SO4 is 2 negative, right, and so then the 2 goes down here. I don't want to see any charges on any of these molecules afterwards though, so I shouldn't see any 3 positive here or anything like that, because it's no longer an ion, it's an element at this point, so it doesn't have a charge, and so there should be no charges on any of them. Okay, and now we need to make sure that it's balanced. So the best thing to do is kind of start with things that are uncommon. So in this case, like the SO4 molecules, there's 3 of them, so I'd put a 3 in front of here. Now there's 6 sodiums, so I'm going to put a 6 in front of sodium. There is 2 aluminum, so I'm going to put a 2 in front of here, and now everything should be balanced. And then it tells us to figure out the mass of sodium, so we have to figure out the mass of this, required to react with the mass of 23.6 grams of this. So the first step after having a balanced reaction is to find the moles of the thing you can. And usually this is the thing you have actual numbers for. So in this case it would be to find the number of moles of aluminum sulfate. And we're going to do this by doing mass divided by molar mass. So the mass is 23.6 grams. Now we're going to have to do the molar mass calculation on the side. So the molar mass of this is going to be 342.17 grams per mole. So now when I do 23.6 divided by 342.17, I get this number. Oops, there's another 0 in there. 689715638, and that would be moles. Now the next step is to figure out the number of moles for the thing I have the question mark for using the mole ratio, and the second step is always, or sorry, I guess the third step here is the mole ratio. So you take the number of moles of the thing that you know. So I'm just going to write dot, dot, dot behind it, and then this is moles of Al2SO4. So now I want the moles of sodium, because this is the one that has the question mark, so I put 6 moles of Na. The 6 comes from the number in front of the coefficient here. And then I want to get rid of Al2SO4. And there's only a 1 in front of this one if there's nothing there, right? So that means that I take the number on my calculator and I times it by 6. So now I get this many moles. Of sodium. Now, last step is to figure out what the question's asking. In this case, it's the mass. So to figure out the mass, we would do the number of moles times the molar mass. And the molar mass of sodium is, I'm just going to check, I think it is 22.99 grams per mole. So now we take this and multiply it by 22.99. And I get, so 3 sig figs, 9.51 grams. That's my answer. Perfect. Let's try some more. So determine the quantity of calcium phosphate required to react with sodium sulfate. So calcium is 2 positive, phosphate is PO4 3 negative. That means that calcium phosphate is going to look like this. And sodium is positive, sulfate is 2 negative, so this will look like this. Okay, these are 2 compounds reacting with each other, so 2 compounds reacting with each other. So this is called a double replacement reaction. So this is called double replacement, because what you really have is almost like 2 dance partners, and they're going to switch partners now. So calcium's going to go with sulfate. Calcium again is 2 positive and sulfate is 2 negative, so therefore there won't be any extra numbers on that one. And now sodium is going to go with phosphate. And remember that phosphate was 3 and sodium was positive, so it should look like that. Now we just need to balance it out. So firstly, I see that there's 3 SO4 molecules here, or sorry, 3 calciums here. So I'm going to put 3 in front of here. Now I have 3 SO4 molecules here, so now I need to put a 3 in front of here. Now I have 6 sodiums here, so I'm going to put a 2 in front of here. And now I have 2 PO4, so now I'm good. Okay, now the next thing we need to do is write down the things that we have underneath. So determine the quantity of calcium phosphate. So we're trying to figure out this to react with 24.5 grams of this. So again, step number 1 is to figure out the moles of the thing that you can. So in this case it would be the Na2SO4. We're going to do this by mass divided by molar mass. So 24.5 grams. And we're going to have to figure out what sodium sulfate is. So sodium is 22.99 times 2. Sulfur is 32.07, and oxygen is 4. So I get 142.05. So 24.5 divided by 142.05 gives me 0.17247 and this is moles of Na2SO4. Step number 2 on the calculation part is to figure out, using the mole ratio, the thing we have the question mark for. So in this case now I'm going to take the number of moles of sodium sulfate and I need to figure out the moles of calcium phosphate. Remember again that you get these numbers from the balanced equation, right? Here's a 3 and here's a 1 in front of here, so here's the 1, here's the 3. So now we're going to take the number on a calculator and divide it by 3. Now step number 3 is to figure out what the question's actually asking us for, which is the mass in this case. So this would be the mass of calcium phosphate. So again, we're going to have to do a couple calculations here first. So 40.08 times 3, 30.97 times 2, and 6 times 16. Oh, 8, sorry, 8 times 16. Okay, so 40.08 times 3 plus 30.97 times 2 plus 16 times 8. It's 310.18. So now we're going to take that 310 and times it by that 574914936. And we want to have 3 sig figs, so I get 17.8 grams. Great. Try one more question. Okay, determine the mass of carbon dioxide produced by the complete combustion of methane. So first off, you'd have to know that methane was CH4. If it didn't give it to you in the question, which often it will just be like right here, kind of behind it, you could look in the data booklet for methane. Methane is one of those ones that I told you guys you should memorize at the beginning. Remember that in combustion, you always have what's called a hydrocarbon. So this is a hydrocarbon because it's made out of hydrogen and carbon. And we have oxygen, and we're always going to make carbon dioxide and water vapor. So we're always going to make CO2 and H2O. It's really important that we know this combustion reaction makes those things. Okay, so determine the mass of carbon dioxide we're going to make this time, and we're burning 1 gram of methane. So firstly, we need to balance it by putting a 2 in front of here, which makes 4 hydrogens so that I have the 4 matching. Now I have 2 oxygens in here and 2 here, so that gives me 4 oxygens, so I need to put a 2 in front of there. Okay, now the first thing I'm going to do is figure out the number of moles of methane that I have by doing mass divided by molar mass. So I have 1 gram, so 1 carbon is 12.01. 4 hydrogens times it by 4, so really that is 12.01 plus 4.04, so divided by 16.05 grams per mole. Next, I'm going to use the mole ratio. Now I want to get rid of moles of methane. So I see there's only 1 mole of methane in the balanced equation. And I want to get moles of carbon dioxide, and there's only 1 mole. So therefore it should be exactly the same number. But now it's moles of carbon dioxide. So 1 balanced equation, 2 moles, 3 mole ratio, and now 4 is whatever the question is asking me for. So in this case, it's the mass. So now we have 12.01 plus 32 for the oxygens. Gives me 44.01 grams per mole. So now we're going to take that and multiply it by our 0.623052996. And I get 2.74 grams that I'm going to make. Good. Okay, next is going on to solutions or gas stoichiometry. You should be able to do all the worksheet problems now on mass-to-mass calculations.